Hey guys, welcome to remote learning, I guess. So here's the deal. You've got one more topic left to learn, and it just so happens that this one topic is still on the AP exam. As far as I know, the AP exam is going to be all free response. You're going to have 45 minutes to answer their free response questions. I have no details on how many questions. My guess there would be 2 or 3 questions. They may even give you all 4 questions just without parts like A and B. It might just be one question, one kind of part per question. So I don't know how they're going to score this. I don't know how they're going to grade it. This is uncharted territory. So we're just gonna have to make the best of what we have. It looks like array lists won't be covered, recursion won't be covered, a couple other things, but I already sent you the links for what would be covered. It's units 1 through 7 as the College Board dictates, but it did have searching and sorting as one of those units because it's one of those things you can take care of with one-dimensional arrays. So we're going to talk about it. We're going to go over kind of a algorithm a day over this week. And today we're going to start with the bubble sort, as you saw on the first screen there. So I'm going to walk you through the algorithm and do some coding and scripting. There's a video actually in the description, so please go ahead and click that real quick. Just pause this video, click that one, watch it. It gives a nice little demo of how the algorithm itself works. So take a minute, pause this, open that one up in a new tab, or however you want to go about it, and come on back to me when you're ready. All right, so hopefully you watched the video, and now we can kind of get into the algorithm itself. So let me kind of share my screen with you here. There we go. Whoops, why did that do that? Okay. So on my screen here, we've got the bubble sort algorithm as it was kind of written throughout the video. So the deal is you kind of have like this wall that you can kind of go up to, and the thing is you want to trickle the numbers up in either ascending or descending order, however you want it sorted. So the goal is to compare 2 elements that are side by side, and if they're out of order, flip them, and then move over to the next 2, or to the one more over for both elements, and compare them, and if they're out of order, flip them. And that way eventually you'll end up with the highest element or lowest element, depending on what you want, all the way to the end of the array, and then you can kind of start back over at the front again and keep doing it over and over and over again. Now, hopefully you notice this probably isn't a very efficient algorithm. It's probably one of the worst algorithms out there, but in terms of practice tests and things like that, and what I've seen on the AP exam, it happens. They do say that this is a bubble sort algorithm and you should know how it operates. You should be able to quickly tell if it's sorting ascending or in descending order, and if it's actually working appropriately. So is it doing it enough times to make it work? And there's a couple different ways to write this. So I've got a nice little flow chart for you to look at here. That you can kind of see what's going on. So let's get that. In this flow chart, what you're looking at is that I've got a bubble sort algorithm here. I'm passing an integer array. I call it int r. And my declarations, what I need to know is pretty much where that wall is. How far do I want to go out? And that's what I'm calling max index. And that's going to be the length of the array minus 1. Because I don't want to go all the way to the end of the array, because I want to be able to compare the element I'm at to the next one in the array. So if I go too far, I'll go out of bounds. So that's what I'm calling max index. And that max index is going to continually shrink and get smaller and smaller and smaller, so that I don't have to traverse the whole array every single time, because I already know the ones at the top are already sorted. So while my max index is greater than 0, I want to declare a new index. I called it index, and that's just going to start at 0, so it's going to start at the front of the array and work my way up to max index each time. So you can see index at 0, while index is less than max index. I want to compare those 2 elements, those 2 consecutive elements, and if the one on the left happens to be greater than the one on the right, I'll swap them. Okay, and so I have a nice swap algorithm kind of already built, and we've done that a million times where we've transposed 2 elements in a list or an array, so I'm not going to go through that in great detail. But if one is on the wrong side of the other, switch them, and then increase index by 1, and keep going through this little loop here until you eventually bubbled up the biggest number to the front of the list. Now, once you've gone through that and the biggest number is already at the front, then you can decrease max index, work your way around, and then start at the front of the list again and start working your way through. But notice this time, since max index went down 1, now I don't have to go as far as I did. And so eventually this inner loop ends up getting shorter and shorter and shorter. But what I'll have then is a sorted list when it's all said and done. So let's take a sec, let's scoot over, and let's try coding it in a couple different ways. Let me get rid of this stuff, and we'll just rewrite from there. So I'm going to write a simple bubble sort, and I actually have a couple others that are down here that I'll kind of poke myself into in a minute. But right now I kind of just work my way through that algorithm and see what happens. So I'm going to call it public void bubble sort. And let me kind of walk you through this class real quick before I go too far. So in this class, I called it list. The list class has a private integer for size. It's holding out how many elements there are in the array, and an integer array. And so I've got my constructor, it sets the size, it builds the integer array based on size, and it assigns numbers to it, and you can see that they're assigned completely randomly. So I get basically any number between 0 and 999, and so they're all just placed in there randomly. I've got a toString method that'll print it out nice and even. I've got my swap method, okay, that's kind of important, which will allow me to pass in two indices. I call them J and K, and it'll simply take the element at int array at J and the element at int array K and flip-flop them, just swap them completely. So I've got the ability to do everything I need to do now. It's just time to write out how to do it. So if I kind of cut back over to the algorithm, I want a max index, okay, and I want to run it while it's greater than 0. So I'm going to say something like this. I'm going to go int max index is greater than, is equal to this dot int array dot length -1. I could also concurrently just use the size field. So this could just simply be size -1. Okay, that's as far out as I want to go for my maximum index that I want to go through. While my max index is greater than 0, I want to do a couple things. Well, if I remember, I want to set a new index to 0 and run another loop while my index is less than max index. So I'm going to go int index equals 0, and while my index is less than max index, this will force me so I'm not going too far. I want to come over here and get in this loop where I just compare adjacent elements, and if they're out of order, swap them. Otherwise, make some changes to my control variables. So let's pop over here and ask the question. If the int array at index is, say, greater, because we want to sort it in an ascending fashion, this dot int array at index +1, we're always comparing consecutive elements, so one right next to the other. If that's true, I simply want to swap the two elements at index and index +1. So I'm going to say this dot swap, and it's only because I've already written this method, index and index +1. Okay, so once that's done, I need to make some changes to my control variable. So this ends the for loop, or ends the if. Okay, this ends the while loop, but before I end that while loop, I want to make sure that I adjust index to go up by 1 each time. Right? So this ends the inner while. Okay. And before I get out of the outer while, the max index, I want to make sure that I adjust that and decrease it by 1 so that it keeps getting smaller and smaller and smaller every time I run through and bubble up the largest number to the front of the list, or to the back of the list, I should say. So bubble it up. Now switch it and make sure that I don't go too far. So over here in test, okay, you'll see that I have an instance of list, and I print out how many elements, or the elements themselves. So let's just run this real quick, and you'll see what it kind of looks like. So I get a list that has an integer array in there, and I print all the elements of it, and I got it printed out nicely, neatly in brackets, and they're completely randomized, and there's my list. Now let's actually do this bubble sort and print it out one more time. So I'm going to take these out, and let's run it one more time. And now you can see it's in ascending order. So this was the original list, and now this one is completely in ascending order. So that's kind of neat. All right. Now this is a nice, neat way to kind of do it. A simple bubble sort using the same kind of logic. Now you notice it's probably more complex than it needs to be. We can obviously use some if statements for this. So I'm going to come down here and write this public void bubble ascending method. Same logic, I'm just going to use for loops instead of while loops. So I'm basically going to take this logic and copy it down here. So let's do something like that. We'll go for int max index equals size minus 1. I'm going to run it till max index while it's greater than 0, and max index is going to decrease by 1 each time. Okay. I am going to come up with another loop. That's my inner loop. That's this part, the while, all the way through here. So I'm going to go for int index equals 0. Index is less than max index, and index plus plus, because I want to keep moving to the right. And let's ask the same if statement. If, we don't need the this in there, but we could write it, so we can go this dot int array at index is, say, greater than this dot int array at index plus 1. If that's true, I want to swap index and index plus 1. Okay, so again, same stuff. Okay, that's up here, just a little bit more compact with the use of for loops. So obviously if I come over here and instead of using the bubble sort, I call the method, bubble sort ascending, it'll allow me to still do the same thing. And you'll see that I still have the same logic. It still produces an ascending list, a sorted list in ascending order, so it seems to work just fine. Now if you do want something in descending order, well, it's not really hard to do. What's the one thing that I would really need to change? Well, hopefully you can answer it and just say this is the only thing I needed to do. I needed to still do the exact same thing. I needed to bubble things up. I just need to make sure that I'm comparing the previous element to the next element, but seeing if the previous element is less than the next element, and if it is, swap them so that I can keep working it. So really I'm going to take the exact same logic and I'm going to put it into this method here. So let's kind of print some things out, but I'm simply going to flip this sign to be less than instead, and now I've got a list in descending order. So let's go ahead and call that method real quick. We'll go dot bubble sort descending instead, and we should see now the list is in descending order instead of ascending order, which it is. Here's my biggest number, working my way all the way down to the smallest, and it seems to work out just fine. Now, that's fine. That's probably what you're going to see on the AP exam is a simple bubble sort, either in ascending order or descending order. Okay, but it is a completely inefficient algorithm, and even if I'm going to write a smart bubble sort, that is still completely inefficient. But I am going to write it a little bit smarter because the fact of the matter is that this continues to run. Let's say it gets through a pass, and the elements are already sorted in that pass. It doesn't stop itself. It keeps going back and passing again and passing again and passing again. So let's write a somewhat smarter bubble sort that could be used to stop doing the passes if it finds that it never swaps anything. Because if it never swaps anything, then it must be sorted. So what I'm going to do here is I'm going to write it slightly different. I'm going to go Boolean sorted. Okay, so I'm just going to create a Boolean variable called sorted, and that's just going to tell me if it's sorted or not sorted. I'm going to create an integer called, we'll say index, and make it equal to size minus 1. Okay, that's as far out as I really want to go. And I'm going to switch up the loop. Okay, I'm going to write a do while here. We haven't done that a lot. Okay, in a do while, okay, we always go through it at least one time, and I want to do this while I'm not sorted. Okay. Remember, sorted is going to be a Boolean variable, so as long as that's false, then I keep doing it. Okay, as soon as it's true, I stop doing it. The thing though is, I'm actually going to set it to true to begin with. Okay, and the reason is I'm going to do that is because if I go through this whole loop and don't swap anything, I want it to stay true. But if I swap even one thing, then that means on that pass it was unsorted, and so I want to try to make at least another pass to see if it is sorted again. And that's going to keep refreshing to true every time this loop kind of goes through. So let's go through and we'll do the bubbling algorithm, which is essentially this. Okay, so we'll go with what do I want? For I'm going to go int. Actually, I don't even need this. What am I doing? Get rid of that. For int index equals 0. All right. And oh no, I do want that. That was called, I'm just calling it the wrong thing. Excuse me. I want this to be max index. For int index equals 0. So for index equals 0, while index is less than max index, index plus plus. Okay. Still the same basic checks. So we're going to go for or if this dot int array at index is greater than this dot int array. Oops. At index plus 1. So if that's true, I do want to make the swap. Okay, so we'll go this dot swap index comma index plus 1. And I also want to change sorted to false. And the reason I'm going to do that is because I made a swap, so I know it's not sorted, at least all the way. So I want to make sure that I have that. So once I'm done with this for loop, then I'm going to take my max index, I'm going to decrease it by 1 for the same reasons as before. I already know that the end of the array is sorted, so there's no reason to go through it. And so that's a smarter bubble sort. It doesn't take as many passes, or at least it doesn't have to. If it finds that it's sorted at some point in time, then it will stop itself. But if it goes all the way to the end, just like the other ones, then it goes all the way to the end with the other ones. So we can give it a shot and see that it works. So let's come over here. We'll make a quick call to a smart bubble sort. Smart bubble sort. And let's just see that it works. And here it is in ascending order. And again, if I wanted it in descending order, I could easily just switch this to a less than sign, and that would put it in descending order. So there's your smart bubble sort. Okay. So here's what I want out of you guys. So looking at these algorithms, I'm going to have an assignment in Google Classroom where I simply want you to write a bubble sort algorithm for the problem that I'm going to provide you with. So I'm going to give you a list of names, so strings, first names or whatever it is, and I want you to write a bubble sort algorithm that can sort them in either ascending or descending order. So basically copying the logic from here, but obviously you're going to use a compare to method, so you'll have to remind yourself how that method works, which is fine. Use the Java kind of cheat sheet that the College Board gives you so that you can see what you're doing, and you'll be able to tell that you're doing it right once you have the list sorted in ascending or descending order. So quick little assignment, take the exact same logic that you have here and see that you can sort that list for me. Okay, and we'll keep that going throughout the week. You'll be sorting basically names, so this will probably be the hardest one of the week. Outside of that, then you'll get into the other sorting algorithms and you'll know exactly what you need to do and call. So take a few minutes there, 5-10 minutes, write that algorithm and then turn it in through Google Classroom. Okay, thanks guys, we'll see you later, and hopefully this remote learning thing works out pretty well. All right, bye.